Hey y'all, it's Miss G here, and it is time for us to talk about 1.4 solving multi-step equations. So please make sure that you've got your notes sheet out, that you've gotten a copy of it, and you start filling it out knowing that these are part of your chapter 1 notes. And please make sure that you put your name, just in case it ends up on the floor in the classroom, I can get it back to you. All right, so let's dive into 1.4. So here we're still talking about solving, okay? So that means that we've got an equal sign because we're working with equations. And now we're going to move into multi-step equations, okay? So let's backtrack to 1.3 for just a second. So in 1.3, we were solving simple equations, or we were solving one-step equations, okay? And an example of that hopefully looks very familiar to you would be x minus 3 equals 7, okay? And in order to solve this, okay, we can put our dotted line there to break up the equation to two sides, okay? And we would look to find which side the variable's on. And then we found out what was happening, okay? And then we said we have to do the opposite of what's happening to the variable. So right now, 3 is being subtracted from x, and so we would choose the opposite of subtraction, which is addition. So we would add 3 to this side to be able to get this to cancel out. If I do one thing to one side, I must do the exact same thing to the other, which would mean I would add 3 to that side, which would leave me with x equals 10. Okay, so just kind of a little refresher there. Now, this idea of one-step equation comes from the fact that we just had to do one thing. We just had to add 3 to both sides, and we were able to solve the equation, and we were done. Okay, so now we're going to move into more complex equations, which mean that we just have more steps that we need to take to solve them. Okay, so all the concepts from 1.3 still hold in terms of inverse operations and how we do things, but now we just have to make sure that we're applying things in the correct order so that we can solve for the variable. So let's fill in these notes. So to solve multi-step equations, use inverse operations to isolate the variable. So and we already know about inverse operations because we've been talking about them with expressions and then also in 1.3. So the opposite of addition is what? Subtraction, okay? And the opposite of multiplication is division, all right? So remember, we use inverse operations, okay, to cancel or undo what's happening, okay? This is some of the words that we use in class when we talk about equations. So we're going to use inverse operations to cancel or undo. So we did addition of 3 to undo or cancel the subtraction of 3. So that's what we're using these inverse operations for, okay? So let's talk more specifically about the steps for solving. So just like we were doing with expressions, there are steps that we can follow because math is very routine. It's very predictable. The rules don't change. If you apply them correctly, then everyone can get to the same answer, okay? And so putting things in a very step-by-step process allows us to not get lost and make equations more difficult for ourselves to solve, okay? So I'm going to give us an example over here in this white space just so that we can use it as a demonstration of these steps. All right, so I have 2 times the quantity x minus 5 equals 10. This is an equation, right? Because I have an equal sign and I've got an expression on one side and an expression on the other. The very first step is get rid of parentheses. Okay, get rid of parentheses. So this is the exact same first step that we use when we're simplifying expressions. So we know how to do this already. So when we get rid of parentheses, that means that we are going to use the distributive property, right? So the distributive property is the one where we do the arcs, right? We do this, doom, doom. Okay, so the invisible multiply over here, if I were to get rid of parentheses, I would have to multiply this 2 times the x, this 2 times the negative 5. So that would update my equation to be 2x minus 10 equals 10. All right, so you can see this was my starting point, and the next line is either going to be an equation, okay, a full equation written out, or it's going to show the change that I made. All right. So every single line has to either be the work of what changed or it's going to be the updated equation. All right, so check, we did step 1. Okay, got rid of the parentheses. The second step says combine like terms on both sides. Sorry, there's a little typo here, on both sides of the equation. All right, and so what I want you to think about is I want you to think about bubble and box. And this is not new to us either. We know how to bubble and box. So if I were to bubble and box my updated equation, I would bubble the 2x because it has a variable with it. This is a variable term. I would box the negative 10 because that's a constant, and I would box this 10 because that's also a constant. Okay, so when they say combine like terms on both sides, this is the one where you bubble and box, but you can only combine things on one side of the equation. So we would look to this side of the equation. So if we were to split this down the middle, when you combine like terms, you can only work on one side at a time. You cannot cross the equal sign. So 2x minus 10. This is a bubble. That's a box. I cannot put these together. There's nothing for me to simplify on this side of the equation. If I flip to the other side of the equations, or the equal sign, I have just a 10. There's nothing else, no other terms for me to combine. So technically, I am done with step 2. We will have some more examples here that would require us to do more with step 2, so just hang with me as we go along, okay? The third step would be that you are going to add or subtract to isolate the variable term, okay? So this is really important because we want to make sure that we do these steps in the right order. So first of all, what is the variable term in this equation? 2x minus 10 equals 10. Well, the bubble is the variable term. So the variable term, if you do your box and bubble the way we've learned how to do it, would be in the bubble. Okay, so we identify the bubble and we want to isolate, which means we want to get it all by itself. So right now, who's hanging out with this variable term? This minus 10. All right, so what is the opposite of subtracting 10? Well, that would be to add 10. All right, and so just like we did with simple equations, one-step equations, if you do something to one side, we must do it to the other to keep it fair and balanced. So I added 10 over here to cancel this out and isolate this term, which means I have 2x equals 10 plus 10 is 20. Okay, so now if I were to bubble and box this, you see where I have a bubble around this, and I would have a box around this. Which makes sense because remember we talked about in 1.3 that we always want it to say x equals a number, or y equals a number, or g equals a number. The variable equals a number. And if we were to bubble and box this, that means that we've got a bubble equals a constant in a box. So now we're starting to look more like what we need the answer to look like, but it's supposed to just say the variable on its own, not this 2. So we have to go to the last step, which would be to multiply or divide to finally isolate the actual variable itself. Okay, so now we want to isolate again, but now we're trying to pare down and get just down to this variable. So we're going to divide by 2 because these are being multiplied together. The opposite of multiply is divide. So I'm going to divide these by 2 and say x equals 10. All right? So if we were to look at these steps, we could almost list them out here. So the first step right here, number 1 step, get rid of parentheses, was this. The number 2 step, where we're combining like terms and looking at bubble and boxing, is right here. Number 3 is add or subtract. Number 3 was when we added 10 to both sides, okay? Number 4 step was down here when we divided by 2. So that was step number 4. Okay, so again, every line of my work is either the updated equation or the change that I make. The updated equation, the change that I make, and then finally I'm able to box in my answer. So the very last thing that we're going to do is check our solution. So checking our solution means plug it back into the equation or plug it back into the variable. Okay. So what that means is I'm going to take my original equation. I'm going to move over here and say 2 times x minus 5 equals 10. This is what they originally gave me, right? I'm now going to take 10 because I said this 10 makes this equation true. If I plug it in for x, then I'm saying that this equation will be balanced. So I'm going to say 2 times, instead of writing x, I'm going to write the 10. And then I'm simply just going to check my work. I'm going to do order of operations, right? I'm going to say 2 times 10 minus 5, because parentheses go first, is 5 equals 10. And 10 equals 10 because 2 times 5 is 10. So I have now checked my solution that 10 is actually the answer for this equation right here. Okay? All right, so you're going to get to keep your steps in front of you. I'm going to go ahead and move this down so that we can actually practice these, okay? So remember to look up on your piece of paper as we're working through these practice questions, okay? The very first one, let's go ahead and do this together. So if we were to look at the very first step, we would want to check if there are any parentheses to unlock. Are there any parentheses? Nope. So number one step, check, done, super fast, right? Step number 2 means we have to combine like terms and we have to bubble and box to see what we could put together. So if I put a bubble and then I would box and then I would box, I take a look to the left and I say on this side of the equation, is there anything that I can put together? Nope, this is a bubble, this is a box, they cannot get put together. I look to the right side of the equation. Is there anything on the right side that can go together? Nope. So step number 2, check, done. Step number 3 says I need to isolate the variable term, okay, by using addition or subtraction. So first I have to identify what is the variable term. I have 1, 2, 3 terms in this equation, and the variable term is 3x because it's the one in a bubble and it has the variable inside. So I want to get this bubble all by itself. So I have to get rid of this box. How am I going to get rid of plus 15? If I'm going to get rid of plus 15, I have to minus 15 from that side to cancel that out. If I do this to one side, I must do it to the other because I have to keep this fair. So that would leave me with 3x now equals 9. So now I have isolated the variable term, right? And I'm able to do my one-step equation where this looks like, oh great, this is much more simple. And the final step is either to multiply or divide. So in this equation, currently 3 is being multiplied by x. So the opposite of multiplication is division. So I would choose to divide by 3. And I would have to do the same thing on the other side. And then I would say x equals 3. Okay, so this was step number 3 where we did the addition or subtraction. This was step number 4 where we had to use a multiply or divide to isolate the actual variable. And then step number 5 in our steps to solving equations would be to plug the number back in. So 3x, so I'm going to say 3 times 3 plus 15 equals 24. 3 times 3 is 9. So I'm updating my equation every line I go, and then I'd say 24 equals 24. Check. Yes, I got it right. All right. So we are going to move down to this box right now. Okay. Number 2. I would love it if you could take a pause in this video real quick and see if you can work through the 5 steps on your own. See how far you can get. If you get stuck, that's fine. Just push play again, and I'm going to talk you through it. All right, guys, so step number 1 is to unlock the parentheses. So we're going to go ahead and distribute this 2 to both of the terms inside. So 2 times 1 is 2. 2 times negative 5x is negative 10x. Then I just continue to write the equation because all I've done is update it by unlocking the parentheses. All right, so now I'm on to step 2, which means I have to bubble and box my equation. So I'm going to do the bubble and box of the terms. This is all things that we've been able to do before. And then I have to look to the left and I say, is there anything over here that I can combine together? And I'd say, yep, because this is a box, this is a box. I can put that 2 and that 4 together because that makes 6. And then this negative 10x is all by itself on this left side of the equation. There's nothing else to combine. So I have now simplified this left side of the equation. Equals, and then this negative 8, there's nothing hanging out with it, so the negative 8 just gets to stay the same. Do you notice that I did not combine the negative 8 with this 2 and this 4? I cannot cross the equal sign in step 2. Step 2, we have to stay on the left side, combine, and then stay on the right side and combine. All right, so if I'm going to move on to step 3, I'm trying to isolate my variable term. And so if I bubble and box, it becomes super clear that this is my variable term. Excuse me. Got the sniffles. My allergies are, they're giving me a hard time. So if this is my variable term, that means I have to get rid of this 6. And so step 3 says I have to use addition or subtraction. All right, so there's the invisible positive in front of this 6. So in order to get rid of a positive 6, I'm going to subtract 6. Okay, that would cancel out, which means I'm left with my variable term equals negative 14. Okay, then I'd say I'm on my last step, step number 4, and I'm going to undo using the inverse operation. Well, this is currently being multiplied, so I'm going to use division to be able to cancel that out, and I'm going to end up with x equals 1.4. Okay, so I know in class we have a lot of examples where I use numbers that end up being whole numbers and we don't end up with fractions or decimals, but I need you to know that decimals, fractions are just numbers, and it's totally fine if your answer is a fraction or a decimal. That's okay, because this 1.4 is the correct answer. When I create problems for our whiteboard exercises, oftentimes I try to use whole numbers because it's just easier for me to gauge what the answers are and do mental math and be able to give you guys feedback very quickly, okay? But please do not be intimidated or nervous or second guess yourself if you end up with a decimal or a fraction, okay? And then step number 5, we would go on ahead and plug this in, right? I'm not going to take our notes time or this video time to do it, but you would plug this in. So I would show you what it would look like. You'd say 2 times 1 minus 5 times 1.4 plus 4 equals negative 8. And you would do this math on the left side and see if it actually equaled negative 8. All right? Okay, let's do number 3. So again, just like I asked on number 2, can you please pause the video, give it a try, and then push play and we'll walk through it. All right, guys. Step number 1, get rid of parentheses. Well, I don't see any, so check. Step 1 is done. Step 2, we're going to bubble and box because we have to combine anything that is a like term on either side of the equation. So I bubble and box and then I look to the left of the equation sign. I see 2 bubbles here, so these can combine to 2x, and then I cannot combine these 2 because they're on opposite sides of the equation. So all I'm going to do is write that minus 25 equals, and then this negative 35 is all by itself. Okay? Step number 3 says I have to isolate the variable term. So if I bubble and box, it tells me what the variable term is. It's this 2x. So I have to get rid of this minus 25 by doing the opposite and adding 25 to both sides. So when this cancels out, it gives me just my variable term. And now I can go on to step number 4, which is to isolate the variable itself, okay, by using multiplication or division. And I'm going to end up dividing by 2, okay, to be able to unlock that variable. And I'm going to have x equals negative 5. All right. And again, number 5, you would check your answer. For sake of the video time, I'm not going to do it, but you would plug this negative 5 into both of these x's, or you could plug it in right here into your more simplified combined terms version of your equation, okay, to check that your answer was correct. All right. Okay, guys, so we're almost there. Keep practicing. I promise the more that you do this and you walk through the steps, you won't even have to look at your notes. You'll just almost automatically just start doing all of the steps. But I really encourage you to go step by step by step in the beginning until it becomes habit, especially as you go through your practice problems, okay? So the very first step would say unlock parentheses, and I see some parentheses here. So I immediately know that I need to distribute this negative 0.04. So when I update this equation, it turns into 1 minus 0.4x, because again, a decimal is fine, guys. It's just like a number, okay? It is a number. It's not just like a number. A decimal is a number, okay? And it's okay to have decimals. 0.4, negative 0.4 times 10 is minus 4, okay? And then equals 2. So whenever you distribute, you should always see that you just have an updated equation all the way across, okay? Because we only make a change one at a time. We don't do multiple changes in one line. So then I would say I'm on step 2. Now it's time for me to bubble and box and figure out if there's anything that I can combine on either side of the equation. So when I look to the left, I say, oh, this 1 and this negative 4 are both just constants. They're in a box. I can put those things together. And then I would just rewrite the equation because there's nothing else that I can combine. This 2 is all by itself, and this 2 does not get to cross over yet, not on step 2, right? Okay, we only combine on one side at a time. So then if I were to continue to bubble and box so I make sure I can identify which term is my variable term, I see this is my variable term right here because it's in a bubble and it has the variable. So I'm going to get rid of this minus 3 by adding 3. Okay? So when I add 3, I end up with this canceling out, and I say negative 0.4x equals 5. All right? Then I'm going to go in and do my final step, okay? And I'm going to unlock this multiplication by doing the inverse, which is dividing, and I'm going to divide by negative 0.4, and I'm going to get x equals negative 12.5. And again, decimals are totally okay. All right? And if you wanted to prove it to yourself, of course, you could check your answer and you come back in and you go and you plug that number in for x, and then you would evaluate each side of the equation to make sure that it balances out and it equals the same thing. Okay? So let's finish up these notes with this very last problem here. Okay? And so getting into our word problems, remember, we're always trying to make sure that we're annotating and pulling the math out of the problem. Okay? So the question says, how many miles do you need to run on Friday so that the mean number of miles run per day is 1.5? Okay, so I see how many miles do I need to run on Friday. So this is the day we're talking about. So that the mean number of miles, what does mean mean? Mean equals the average, okay? So when you think about mean, median, and mode, we're assuming that you have some knowledge about that, and that lets you know that you add the numbers together, right? You say number plus the number divided by how many numbers there are, right? So in this case, I divide it by 3, okay? So that's what we mean. This is just an example, okay? All right? And it's saying number of miles run per day is 1.5, okay? So they're saying they want the mean to equal 1.5. That's what I got from this right here. The mean number of miles per day, they want it to be 1.5. So now I've got to go back and kind of reverse engineer this. I have to say, well, how many days are there? 1, 2, 3, 4, 5, right? Okay, so I'm going to say that I'm going to have 1.5 equals, and I'm going to have to say, okay, well, what if I were to do the average? I have to sum up the numbers and then divide by how many there are, right? So I would know that 5 goes on the bottom because I'm going to have to divide the sum by 5 because there's 1, 2, 3, 4, 5 days, right? Then I'm going to go in and fill in these numbers to say, well, I ran 2 miles on Monday. I ran 0 miles on Tuesday, right? I ran 1.5 miles on Wednesday. I ran 0 miles on Thursday, and I'm running X miles on Friday, which is what I really, really want to know. So when I talk about word problems, I want to define what my variable means. And X equals the number of miles ran on Friday. Okay. So let's see what we can do in terms of thinking about this, all right? So if I were to simplify kind of this top piece, how many miles have I run for the week so far? Okay, well, I've actually run 3.5 plus x and then divided by 5, because this 2 plus 1.5 plus 0, I'm just kind of updating and simplifying this piece, okay? If this were in parentheses, I'm just trying to simplify what I can. Is that okay? All right, so now we have to think about how we can solve this equation, right? So I'm going to see here that I have to get rid of this divided by 5. Do you see how it's all the way across right here? Okay, that means that this whole piece is being divided by 5. So to undo divided by 5, that means I would multiply by 5, right? So I would say 1.5 times 5 is 7.5. I'm going to come over here. Okay, 7.5. Okay, so that cancels that out, but 7.5 now equals 3.5 plus x, right? Okay, so if I were to kind of get into my steps, okay, instead of just kind of to think through the word problem, I would say, okay, well, if I were to bubble and box this, right, this actually is just a one-step equation now. All I have to do is get this by itself by getting rid of this 3.5, which means if I minus 3.5 from both sides, then I'm going to come up with 4 equals x. Is 4 one of our answers over here? Ah, I see it here with C. Well, before I would, oops, oh, hold on. The pen's going crazy. How do I, okay, there we go. Woo. Okay, how do we, there we go. So I see that 4 is an answer, but I would like to check my work, because when I submit my answers, especially on tests, I really want to double check what I can. So I want to go plug this number back in here, right? I want to plug it in right here. So if I were to say x equals 4, that means I'm going to say 2 plus 1.5 plus 4, because the zeros, right, aren't going to change anything. And I'm going to say 2 plus 1.5 plus 4 is 7.5. Okay, so 2 plus 1.5 plus 4, and then plus the 2 zeros, equals 7.5. So that's how many I ran total, and I have 5 days. So what is 7.5 divided by 5? Well, 7.5 divided by 5 is 1.5. All right? So I wanted us to be able to think about these word problems where we think about what do we know, we might have some prior knowledge we need to know, and how can we start writing it in equations even though maybe you logically could have figured out that this was a 4 because you knew how all of this mean and averaging worked, but let's start trying to write it in the math language and the math notation. All right? So whatever questions you have, let me know. Bring them to class. We're going to be working on your practice problems and whatnot, and hopefully get really comfortable with this multi-step equations. All right? See you guys later.